I'm based out of the MS Technology facility up in Beverly, Massachusetts, and I'm with Waters Corporation. We provide chromatographic, chemistry, mass spectrometric, and thermoanalysis solutions for your analytical needs. But what I'd like to talk about today is some mass spectrometry, and I want to stick along the theme of what was talking about getting more quantitative information from our qualitative analysis. And this actually kind of goes in what I talked with about last year when we released our Xevo TQ instrumentation that is a quantitative platform and had increased qualitative capacity. So I'm kind of talking about bridging that gap, the ability to do both analysis on one mass spectrometer. And some of the challenges we see in this kind of analysis is the ability to analyze these complex samples and get more information out of them. So we can argue the benefits of ultra-performance chromatography and getting the most out of our chromatographic hydrophobic separations and having the mass spec keep up with that. We've been doing that for 5 years now, so I'm not going to discuss that. The second part about our qualitative analysis system is the ability to get information on individual precursors and product ion information for each one of those precursors using our novel MS to the E acquisition. We've been doing that for 3 years. What I want to focus on now is getting more information in our quantitative solution. So I'm going to talk about the next generation of high-definition mass spectrometry, and that's on the Synapt G2 platform. So it's a tandem mass spectrometer. It's based on a quadrupole time-of-flight mass analyzer. And actually here where a collision cell normally is, it's actually an ion mobility collision cell kind of device. And I'm going to focus on the TOF analyzer and the ion mobility separation. So what have we done in this iteration of the instrument? Well, we redesigned the whole TOF analyzer from the pusher to the reflectron and to a novel detection system. It's a hybrid analyzer which gives you the best of both worlds of low ion detection of a TDC and the dynamic range of an ADC. The other thing that we can also do is, while this analyzer requires at a rate of microseconds, we're able to couple UPLC separations on the order of 1 to 3 seconds with millisecond ion mobility experiments. So we can do LC, ion mobility, and MS all in the same run with excellent capability. And that is typically 40,000 resolving power, 1 ppm mass measurement accuracy with a dynamic range of 5 orders of linear quantitative and mass measurement dynamic range with a sampling rate of 20 hertz. So the resolution is independent of our scan rate. It's constant across that. So what do we expect? What do we gain here? Well, we should get 5 orders of quantitative dynamic range. Here I show you 4. We're using narrow mass extraction windows to get the specificity, and we can get good quantitative dynamic range, okay? Now, we can also look at different kinds of quantitative dynamic range. Here I show about 5 orders of in-spectrum quantitative dynamic range, and here I have 4 orders of quantitative dynamic range in spectrum in the presence of other ions. So in this mass analyzer, there's almost limitless space charging. In other words, you can get this kind of accuracy independent of how many ions are coming into the detector, okay? So, sorry, let me just back up a second. So one of the things that's problematic in these analyses is, was talked about at this meeting earlier yesterday about the possibility of there being background chemical noise, which limits your limited detection and quantitation, or co-eluting species, and that could be problematic. And I'm going to focus on the bottom half. What was needed was an orthogonal separation. So what is in this mass spectrometer is an ion mobility separator. It separates molecules based on their shape, not just their size and mass. And what we've done on this instrument is we've increased the ion mobility separation by 4-fold by making it 40% longer, increasing the pressure, increasing the voltages and the wave velocities. And what does that boil down to? That boils down to better separation. So here's a situation where we have 2 isobaric peptides, and on the old generation of instrument, you cannot resolve them. On the new generation of instrumentation, we could, okay? And that's actually came out at the same time where the Bowers group released a 2-meter kind of high-performance ion mobility separator. And you can see we get the same kind of performance in this commercially available system. So now you ask, what about that? Well, let's say we have two components in one of our analyses after the hydrophobic separation and high-res mass measurement, okay? So we can see our two components co-eluting at the same moment in time. And what happens is we can't pre-select them with our MS selection device. So if this is an unknown compound, how can we get a pure product ion spectrum? Well, we simply can extract them using the ion mobility and fragment them after the ion mobility separation. So we can get all the products of all the precursors all the time with the mobility experiment at the same time. So we're getting increased sample definition. And basically, we get ultra performance in MS and MS mode with novel orthogonal separation that you can't get elsewhere.